Welcome to the Future of Power podcast, where we explore how fault-managed power is revolutionizing energy distribution and driving a smarter, safer, and more sustainable future. As the inventors of fault-managed power, VoltServer is at the forefront of this transformation. With FMP now part of the National Electric Code, this breakthrough technology is entering the mainstream, unlocking new possibilities in power delivery. In this podcast, we bring together industry experts, innovators, and thought leaders to discuss the challenges, opportunities, and game-changing potential of FMP. Join us as we have meaningful conversations, share insights, and explore what's next in the future of power.
So our customers typically have really hard electrification problems. And what we found over the years are that these problems are often super interesting as well as really important for the world. So we decided to create this podcast as a way of sharing what we're learning with the community, and when it's appropriate, also explaining how digital electricity can help. In this first episode, we're going to explore one of the most pressing electrification challenges in the country today, but it's not related to data centers or EV chargers, though we're definitely going to discuss those use cases in future episodes. But it's just as impactful. In fact, it's going to affect the lives and finances of at least 80 million people in North America. It's the challenge of replacing gas with electricity for powering heating and cooking. New York City is the epicenter of this effort. About 70% of the nearly 4 million households in New York City still use natural gas for heating and cooking. But for regulatory and infrastructure reasons, those households now need to rapidly transition to electricity. And what you're going to see today is that this is an enormously difficult task using traditional electrical methods. Then, during the second half of the episode, we're going to discuss how digital electricity can radically simplify this task. Joining me today are three people that have a very deep understanding of what's going on there. Steve Eaves is the CEO and founder of VoltServer and the inventor of digital electricity. His invention and promotion of digital electricity led the NYC to create an entirely new class of power called fault-managed power. And this is the first time they created a new class of power in nearly 50 years, so it was an enormous accomplishment. And that's why you'll often hear people referring to digital electricity and fault-managed power interchangeably. We also have two guests from Southwire, one of North America's largest wire and cable manufacturers, including digital electricity cable. In fact, about half of all homes in North America have Southwire cable inside them, so we're super honored to have them with us today. First, we have Bill Fowler, Director of Business Development for EV Infrastructure. He also has around 20 years of experience in the construction industry, so he has a very holistic understanding of how power distribution impacts the sort of retrofit we're going to talk about today. We also have Joe Fawcett, who is a manager of business development in Bill's group. And conveniently for us, he was also a local 3 electrician in New York City for 15 years. So he has a very visceral understanding of an electrification project in New York City. All right, so let's dive right into it. Steve, we've spent a lot of time over the last year in the electric rooms of very old buildings in New York City. Can you level set us and just give the audience an overview of what exactly the challenge is in New York City, what's going on, what's driving it, and why it's so hard?
Yeah, thanks, James. I feel like I should start with one of the really important items from that experience. These buildings are actually pretty nice inside. They're pretty well built. I found them pretty clean, except when we go into some of the bowels of the buildings, like the electrical rooms, which is a whole nother story. But they have a big problem there, and they're trying to upgrade buildings and also take care of folks' day-to-day life while they're doing it, right? So disruption is a big part of the problem. So you're trying to upgrade really old electrical systems for new appliances and not try to displace the people living there at the same time.
But why do we need to upgrade them? What's the situation? Why do these buildings need to upgrade their electrical?
Well, I think the top line item that people often talk about is Local Law 97, and that's the decarbonization effort going on in the city. And it has a series of stages in it, and buildings will be fined for their carbon usage over a period of years coming up. It actually started in 2024, and as we approach 2030, the fines get really steep. But I think what we learned there is it's actually a bigger problem than that. Some of the buildings that are there, actually many of the buildings, also suffer from very antiquated gas lines inside the building. And we found that a good chunk of them have been shut down. So the gas systems have been shut down in the buildings, and then the people have lost their gas cooking. They often still have heat because it's centralized in the basement. But it's a pretty tough problem. I mean, it's a combination of environmental concerns, but also just the practical aspects of post-war era buildings have old gas line systems. And when there's a leak in one of those things, it's almost impossible to find it. So the city, when somebody reports something that smells like gas, the city comes in and there's a series of tests they run. They run pressure tests. And the feedback that we got is it's almost impossible to pass that test in an old building.
Yeah, one of the stats that really shocked me when we first started looking at this market was the fact that the median age of a building, like a high rise in New York City, is 90 years old. And so, these buildings were simply not designed to move so much electricity through them. It's like 70% of the buildings are still using gas for cooking and heating. And now, with local law 97 and these failing gas lines, suddenly you have to increase the amount of energy or electricity moving these buildings by 400 or 500%. And that's just what we'll see is that's just physically, it's not practical in many cases.
I remember one more that we had talked about in the past, that with local law 97 looming in the future, with fines coming up, and just the concept of gas systems being antiquated, and those gas systems also feed steam boilers, and the steam boilers are old, and the pipes that go up into the apartments from the steam boilers are also very old. The owners of the buildings are stuck with this quandary of, okay, I have 4 or 5 years left in the operation of my boiler before it completely fails or becomes impractical to repair.
Yeah.
At this point, do I just bite the bullet and upgrade everything to heat pumps?
Yeah. So now imagine a bunch of these buildings, right? They have to decide, it's not worth it. They're not going to take the chance to invest in a gas boiler for the next 5 years, and they're going to electrify. So Joe, you're an electrician in New York City, for a long time. I imagine a building owner calls you and basically says, listen, we have 40 amp panels. We want to upgrade. We want to install, heat pumps and induction stoves. Like, take us through the process of what it's going to be like transitioning that building, to a fully electrified building using traditional electrical practices. Okay.
All right. Yeah. Thanks, James. When you think about modifying, renovating a building and upgrading the electrical service, the heating, cooling, and the cooking are really our biggest electric demand factors in the dwelling unit. Mm-hmm. And in these old existing buildings, there's not space to really run new risers, because I need to, not only increase, conduit, but also get larger wires through these buildings. And you add in the complicated factors that they're occupied, right? And as a landlord doesn't want to take units out of rent use to upgrade them. So there's a significant cost and time pains involved in trying to upgrade those, kind of the old fashioned conventional way, where we're going to, maybe change that up to 100 amp service. That is a big detriment to trying to do this, right? And so that's where the fault managed power, I think, shows a lot of advantages, if that makes sense to everybody.
Yeah, and what about, so you have the feeder problem, right? You don't have enough space in the feeder. And what about do these buildings have enough service typically, or does that have to be upgraded also?
Yeah, right. So if I'm upgrading the capacity of each unit, that's then going to cascade into the service in a cellar coming from Con Edison, right? Now we need to look at, does Con Edison have enough power on that local network to supply, if you were going to upgrade it, to actually be able to in a timely fashion? It might be a years long process for the utility to allocate the amount of power that you're needing to change that building over using conventional methods.
Yeah. And Bill, what about okay, so you have this the electrician gets in there and you have this problem about just the feeders, not having enough space in the feeders and probably have to upgrade the service. But from a GC's perspective, like, what other pains like points do you see?
Well, and James gives a good question, but what you're seeing from a general contractor's standpoint is, again, these buildings are 100 years old. Like you said, 90 to 100 years old. So typically what they allocated space for bringing power up in the building back then is not adequate for today's standards. So, you see quite a bit of those buildings where people have gone back and used elevator shafts. They've used, other methods of getting that power up. And, I've dealt with situations where your riser was full. There was no option to either go outside or inside. What do you want to do? You've got to get that power up through there. Just to Joe's point, the utility may not even have the service to be able to upgrade that much. As you said, a lot of these panels are 40 amps in the day for that, one light bulb or whatever. Now you're trying to go to 100 or so. It's times how many thousands of apartments are in there. So that's a big undertaking. But also, as you're dealing with 100-year-old buildings, which you have other problems like asbestos and stuff like that. So you start getting in and tearing things out. You get into abatement issues. So again, our older buildings sometimes can be a ticking time bomb to what you don't want to touch things, lead paint, asbestos. So there's all these other factors when you could take an apartment out every floor, make a new riser, but look at what you may disturb and now have to move everybody out. So older buildings really have their unique challenges, and not only just the way they're built, lack of riser space, but also materials that were used back in the day that are not allowed today, Yeah,
just one project we were working on recently. Their plan, the issue they have is, right, they have to build these new risers. They have hundreds of units. And so, it's going to take about a week of work, right, to put, build the new feeder and the branch circuits into the apartments. And so what they're doing is they have to move these tenants out, like about a dozen at a time, cycle them out of their apartments into these temporary apartments that they have to build to house these people for the week while they're, while they don't have heat and they can't do cooking and they don't have, inside their apartments. And so this cycling, right? This cycling adds months. Not only does it add months to your timeline, but now they also have to deal with all these like just the human relation, like management of dealing with moving these people in and out of their apartments for several months.
Yeah. That is a logistical nightmare. I had to deal with that when I worked at GT in the days. Restacking a building that we had to move people off one floor to make it, we call the float floor, right? So they have to move everybody down there to have them be able to have a space to work. Tear the floor apart, remodel the whole floor, and then move them back. And you're looking at 100 to 200 people a floor, and I'm having to pay extra to do it overnight because I just can't not have those employees working for a week while I move them. And the same thing with the disruption of these customers is moving them. That time factor of moving that one project to a 10-story building took me a year.
Wow.
So I'm having to move them down, redo the floor, rip everything out, demo, put everything back, and then move them back, and then, move the next floor down and repeat the process. That was a year long for 10 floors. That was a year long process. So, think of this at how many can you do at a time? Spare apartments and move them. But it's just the logistical. It is a logistical nightmare. Yeah. But you're dealing with
Bill's
people's personal stuff.
Right. To Bill's point, in addition to just the management, moving people in and out, the additional expense of covering the cost of all that, right? You're going to have you're basically decreasing your number of units that are rentable at any given time. Right. And that's a significant dent in the bottom line on a owner of a building.
Yeah. One thing we heard on the contractor side a lot is that the labor practices call for you pay everybody no matter what, whether they're standing, waiting, or whatever. And it's really hard to coordinate all the people. Sometimes you're supposed to have the apartment for a day and they were supposed to let you in, but they're like, grandma shows up or something like that. And then they change their mind. And then you got people stacked up that you still have to pay.
Yeah, Steve, to that point, right? The labor rate in New York City is not the highest in the country, but it's, probably top 2 or 3. the prevailing wage there breaks down to cost the contractor about $2 per minute per person.
Wow.
Or $120 per hour.
Mm-hmm.
Right. And we were doing a job. It was an old renovation, but we had converted a commercial building to apartment buildings, so 720 units in downtown Manhattan. It was a commercial building that had sustained a lot of damage during 9/11. And, so the project was, full demo, and then we built out the apartments. So more or less new construction, dealing with some of the old aspects. But this was at a time when a new type of circuit breaker was required to be installed in bedrooms for circuits feeding bedrooms, and they were defective. They turned out from the manufacturer. There had been a recall on them, so the building was now fully occupied, and I had to have basically 2 or 3 guys stick back, probably for about 3 months after the job was over, to go in and change those breakers out, that the manufacturer resupplied us. And on those coordination issues, well, now we have people living in these units, so I couldn't just send my people there. I need to have personnel from the building there also, so the superintendent and his maintenance staff, we kind of had 3 teams of people that just had to go to apartment to apartment. And again, you schedule it, and then you show up, and it's like, oh, that person had hot yoga that day. And, the other person was on a trip to Europe, and you couldn't get back in, so you just had to keep kind of doubling back. You couldn't work in a really smooth sequence, right? Which just drives your timeline down the drain.
Yeah, I did this quick back of the envelope calculation because what we heard, the planning for this particular project was, okay, we're going to move them. We need to be in the building, in their apartments for about a week, about 5 days. But it takes 2 days to move the people in and out, right? They have to move them in there, and then they move them out. They clean up the apartment, and they move the next group in. So basically, you have 2 days at the front end and the back end of the work in the unit that is just moving people in and out. And so you're working the building 5 days, and then you're moving people in and out 4 days. And so almost half the time is just the logistics of moving those tenants around. And so there's just this incredible value that these guys can create if they can do this work with the tenants in place. Steve, can you, we've done a ton of load calculations. That's really helped me understand how tight the constraint is for these guys. I don't know. I don't want to put you on the spot, but, can you kind of just quickly summarize what it looks like for an average apartment with 40 amps who's currently using gas, trying to switch over to electric, just so we can kind of imagine what options they actually have to accomplish that?
Oh yeah, that's an easy one, man, because the replacement of the gas stove with an electric range, right there is a 40 amp or a 50 amp circuit.
Mm-hmm.
And the majority of the panels are 40 amps. So you've consumed the entire capacity of the panel box, the load center, with just that one change.
Yeah.
And then you're also adding typically a heat pump, or what they call a PTAC heat pump. That's a unit that fits in a sleeve that goes through the wall of the apartment. And so you have that load too, which we find actually when you run what they call MCA on it, right, the minimum circuit amps, it turns out that's about, for the modern ones, about 2,000 VA for that. So that's, another 10 to 15 amps at 208. So the apartments are usually 208 volts, single phase load centers.
So what do you do? Anyone, Joe, Bill, Steve, if I have, what are my options, as an electrical contractor to deal with this if I have a 40 amp panel? I know it's a stupid question, but I just want to level set. What are the options for getting enough power to that unit?
Well, like I said, you got to upgrade your service, but basically the person in the apartment is going to become their own load sharing device. You're going to unplug one thing to plug another one in. Being honest, that's what happens quite a bit, is that you've only got so much power, and they become their own load sharing system. But you're having to upgrade that. So you've got to look at, riser constraints, but that's where the digital power, I think, is the thing, is that you can get what you need up there, in a smaller cable. I mean, you look at just the physical constraints of bringing any new service up. There's just no room.
Mm-hmm.
And that's where we saw, and I think we shared the story before about Europe, is that, how did cable tray get so started in Europe as a support structure? It was the efficiency of being able to use 100% of its fill area versus a conduit where you can only use 40%. So, you think about that, is that if we do in New York, which they require a lot of times conduits, you can only use 40% of its area. Mm-hmm. So by using the digital power like data, we can put that in a shaft environment, a riser type cable. You're not having to put it in something that's already constraining you even more.
All right. So I don't mean to cut you off. This is a good transition. I just want to give, a lot of people listening probably don't know what digital electricity is yet. And so maybe we should take a step back. And Steve, so we're facing this problem. I guess this is like the big punch, right? Where these contractors are facing this problem where they suddenly got they have 40 amp panels. They really need 100 amp panels, right? And so in order, they have to upgrade the service. They have to get a new feeder up there. They have to upgrade the panel, and there's just no space to do that. So they end up, they either have these renovations that take years. Just waiting for Con Ed for a service upgrade could take years. And so what we're leading to is that digital electricity can vastly or dramatically simplify this. So could you do us a favor and give us a little background about the history of digital electricity, what it is, why you invented it, and how it can how it could help solve this problem?
Yeah. Okay. So you gave a pretty good intro at the beginning. It's digital electricity is what it sounds like. It's a digitized version of electrical energy transfer. But in effect, what we do is we send electricity in what we call a packet, which is a little burst of electrical current. And then after that burst, we isolate the transmission lines between a device called a transmitter and another device called a receiver, and perform a series of tests on those lines. And this happens very quickly, like 500 microseconds in duration. And during that time, we can tell if any type of fault has occurred, whether somebody's even touching the conductors of the line, or if there's an arc fault or a ground fault, or there's a resistive fault, like poor connection. All that is part of the protocol of digital electricity. Why was it invented? It originally started trying to figure out a way to charge electric vehicles on an energized road surface, like an electrical road where voltages are exposed at 300 or 400 volts. And to do that, we had to find a ground-up way to distribute electricity so that it could be both powerful and safe, which has always been the historical compromise in electricity, is that you can have really skinny wires at high voltage and sacrifice safety, or you could be safe at low voltage and sacrifice power. You couldn't get both. So digital electricity gives you both. It's high voltage, but it's also high voltage that you can touch with your hands, and it won't ignite a building surface. So that lets it run with the same practices as Ethernet cable. So however you would run an Ethernet cable or your USB cable going to your computer, those are the same technology or safety class as digital electricity.
All right, Bill, Joe, imagine you're like, we're sitting in a room, you're hearing about this for the first time. You guys are like you're renovating and retrofitting a building, and Steve just pitched digital electricity to you. What questions do you have? I just love the questions that come up whenever we bring up digital electricity for the first time.
Well, I would say at first it just sounds like witchcraft. Right? It's magic, yeah. Right? But when you start to just think about how electricity works, right? I can and understanding how the safety functionality of this works, right? If I can pump a much higher voltage through there, I have less power loss through voltage drop, right? Particularly in a situation where I might be starting off from the basement. So that's like a major advantage, right? So the first kind of hurdle to overcome is just like, how does this work and how is it actually safe?
Mm-hmm.
And then once you start to dig into that, and talk to the Steves of the world that created it, it's like, okay, that kind of makes sense, right? But now the next thing is like, okay, is it accepted in practice, right? So okay, now in the latest 2023 code, we have a chunk of the code that talks about this and how to deal with it. And so okay, the code's accepted it. Does the local authority then go ahead and adopt it?
Mm-hmm.
Right.
Okay, but New York, like we're talking about New York, and New York hasn't accepted. I'm going to be the devil's advocate here, play devil's advocate. The New York hasn't accepted a 2023 code. So why are we talking about installing this in New York? Steve, if you want to take that.
Well, we have two, like we've been installing since 2014. And initially we installed under Article 725 of the Electric Code. What we call our Generation 2 products, which is what's out in the world mostly right now, are what's called LPS, or Limited Power Source Qualified Products. So they go through a test under a standard called UL 62368-1, and it tests that they won't, shock somebody or start a fire in a building. And so that's how we started. And Article 7, I call it a grab bag of technologies. Like there's all sorts of devices that are covered in Article 725 of the Electric Code. Mm-hmm. But it's confusing because there's so many things in there. So the, UL and NFPA, right, the sort of, let's call it the safety community, decided that it would be best to create, because it's such a unique technology class, to create a whole new class of electricity that they call Class 4. As you pointed out, it was about 45 or 50 years ago, the last time they did that. So under that class, it's a lot more clear how to do it. But in areas of the country now, we still have to install under LPS while we're waiting for the states to adopt the latest code. And right now, I believe New York is still back in 2020. So the 2020 version of the National Electric Code. So one thing is that inspectors have the ability and actually the obligation to consider newer technologies. So we could install under New York City code as an LPS under Class 2, Article 725, or what we're hoping to do is through education to allow the Class 4 to be accepted. And inspectors have the ability to do that, but it will take some education to adopt things in code that are later than what the current municipality is using.
Yeah, and anytime you have something newer technology coming on board, even though it's been around for a while, right, is getting the folks educated up, because most inspectors, most electricians, even most engineers know what they know when they came in, right? You'll have code arguments with folks and they're like, it's in the code. It's like, okay, let's open up the code. They're like, I swear it was in the code. It's like, well, it was 25 years ago when you learned the code, right? When you first started. But, a lot of folks don't spend a whole bunch of time in the code other than the stuff they're specifically working on, right? So when something new is creeping in, the education aspect, and right, I'm part of why we're all here today is to get this information out there and get people thinking about what can be done. And, when something makes sense and it's explained properly, people start to go, okay, that makes sense. How can we make this work, and where does it fit in this requirement?
Yeah, that's, that brings up a really good point, is code understanding. Can you do it? There's still so many people out there that don't realize you can. I saw this back when Ethernet, PoE came over. We saying the same pushback. Can you do that? Over a data cable. It's accepted now, but it's back then it was taboo, is to say, you can run power over an Ethernet cable. Well, there's already power going over it. It's just a different type. So there's a huge learning curve in the industry that we're so far behind. And, you see these, you talk about pushbacks is the areas and the code that they've adopted and what year they've adopted. I still have some people in 2016, 2014. And it's 10 years old. It's, but you deal with that in the industry is knowledge and who accepts what. And plus New York, I think, Joe, you correct me if I'm wrong, don't they have even their own little New York standard that they like to fall under too?
Yeah, I mean it's a lot better. When I started, we didn't even follow the National Electric Code. New York City had its own complete electrical code.
Wow.
And then later on they moved on and adopted the New York the national code with amendments, right? Which most jurisdictions do. They still sometimes have their own local amendments to the national code, but it used to be a completely separate code.
It's interesting because we're saying that there was a learning curve and some hesitance towards power over Ethernet. And now digital electricity, we often describe it as it's like power over Ethernet. You install it exactly the same way, but it distributes over 20 times the power over 20 times the distance,
Right.
in that pair. And so people are like, that just can't be. Like the last meeting we were in, the guy was just like, just stop. He's like, this is not Star Wars. Stop talking. Stop saying that.
No, he called it Martian shit.
Oh, Martian shit. That's it.
It's so funny. I was just at a conference dealing with some independent electrical contractors, and they're like, "Yeah, POE." I'm like, "This is not POE." I'm trying to get them to understand it. So you're right. It's just that acceptance and that understanding of what it is. That's a huge hurdle in all of this.
Yeah, people can't get over, like, no matter how often you say, they just keep calling it low voltage because of the wiring method. And we're like, we constantly say, we just want to clarify this is not low voltage. We're distributing up to 350 volts. But you can install it the same way you install a low voltage cable. And that's just, after, decades of people associating Article 725 with low voltage DC, it's just it's going to take a while for people to get out of that mindset.
Well, it's funny you say that. I'm going to just kind of digress a little bit. But when I first came to Southwire, I came from low voltage industry, meaning data. Mm-hmm. And I got here and they would say low voltage. And I said, oh, yeah, some Cat 5. They're like, no, 600 volt. I said, no, that's high voltage to me. And they're like, no, that's low voltage to us. So it's funny how you say those terms.
Yeah.
And your background is, and when you start throwing these out there and you assume people are saying that, they're like, no, that's 600 volt stuff. No, I'm like, no, I'm talking about data stuff,
Yeah.
And so it's even when you say that term low voltage, it's what are you referring to? Low voltage power, big 600 volt stuff, or I call big 600, but 600 volt, or the digital power or what we call PoE. I think we actually, in the code, they're having to define all those terms because there is confusion. They're having to separate all that out because of the language that we use in this industry needs to be more defined.
Yeah. 2026 code is trying to clean a lot of it up in a couple steps, but it's separated into limited energy sections versus lighting and power.
Yeah, I don't want to toot your horn, Steve, but that reorganization of the code is being driven by your invention. Am I giving you too much credit?
Yeah, that's a good chunk of it. Yeah, when fault managed power came along, I think that just tipped the card over. Right? Okay, we gotta sort this stuff out.
Yeah.
Because out in the field, right? Like it's a nightmare for licensing boards because they're trying to figure out how training is organized, what things are trained as, what traditional wireman or journeyman class installation versus what they call integrators, which are typically limited energy or quote low voltage folks.
Yeah, and and Steve, you probably see this as I saw this early in the data days when you were going from different type systems. It was the manufacturer kind of driving the wiring standard versus the industry, and I think you're kind of seeing the same thing. Is we used to have token ring or Ethernet or thin neck, thick neck, Ethernet, all these different wiring types, and it was a manufacturer that was driving. There was no really standard till 10 base T was ratified, and then quarter category cable. And I think you're kind of going through that whole same evolution with this, even now the code is how do we get more specific? Because I can tell you, even at the trade level where they're teaching this, it's such taboo. They don't know what to really, how to refer it, and they're not teaching it. So it's something that we got to change in the industry.
I agree.
Okay, Steve. So we have this digital electricity or fault managed power product. So now you can install a power distribution system that's can power, an induction stove or a heat pump, but allows you to get the power there using low voltage wiring methods. So take us through the scope of work, right? Of retrofitting this 200 unit building with a bunch of 40 amp panels. What happens now? How do they do it?
Well, I think, it starts from looking at what they call the load letter, right?
Mm-hmm.
Looking at what the loads are in the building and what is coming into the building, the service for the building. And, part of this technology is not just getting the power from one place to another, it's how you manage the power. And so the increase in electrical demand in buildings is way beyond what we call brute force techniques. So you just can't slam it in there with a hammer. You have to think about how you use the power in modern buildings in order to make it all work, because there just isn't enough out there to get it done, particularly in New York City, right? Because you got, you go out in the street and the vaults, or where the transformers are for the building, are often under the ground. And to ask for more power means they have to dig those things up and shut the road down. So you're talking years. I think, James, we've seen that in a number of conversations. It's a couple years just to start talking to the utility about that.
Yeah, they say if you have to talk to Con Ed, everything stops. That's what they say. If you can help us avoid having to call Con Ed, that's a huge win, because it just stops everything for 2 years.
Yeah. So we look. Often what we find out is that the service entrance can actually do it with load management. So if you think about the aspect of the building, the design point for the apartment is a cold Thanksgiving day. So, people are running a lot of appliances, and if it's cold, then your new heat pump is going to be cranking. Mm-hmm. And so that's kind of the design point, and using, what they call demand factors in the code, which is how, you don't just line up all the loads and put them on top of each other, sum them all together. They're not all on at the same time. So applying the demand factor for the building and some load management, what you might do is if the electric induction range is drawing a lot of power, then you'll electronically turn down the heat pumps. And nobody noticed. For one thing, you're already making heat with that range, and the building doesn't get cold right away. For the short period of time, you're bringing up, the peas and the mashed potatoes and boiling water. You're putting a little bit of heat in the apartment, and you can turn it off. So that's part of the process, is to look at the incoming service entrance for the building, and then see what kind of load management practices are need to be done, and then you find out whether you need to upgrade the service. So we often find out that you don't have to upgrade it if you use load management techniques. So once you have that, then you have your power demand that's required. And as I mentioned, there's transmitters and receivers. The transmitter systems look like a data center server rack. If anybody's pictured those 19-inch rack IT racks that are in the basement electrical room, and they project power often through places that you wouldn't expect, because the wires are so small. And using class 2 practices or class 4 practices, you can put them in things like trash chutes or laundry chutes. That being said, you still need to follow wiring practices that are proper for that installation class. For example, riser rated cable, proper fastening along the way. following code practices for that installation class.
What about conduit?
It's not required for class 4, class 2 power. But as I mentioned, you still need to use the right cable and attachment practices. It's also another big one is that the spacing requirements for class 2 or class 4 they don't have the same requirements as what we call chapter 3 power, which would be, say, MC cable, metal clad, where you have to provide separation. So you can be pretty tightly packed because it's so efficient, the power transfer. And then one technique that is popular in the building, as you're transferring from a vertical riser to a hallway, there's a number of different raceway products that blend into the building architecture. So you have, for example, cove molding that also carries cable. So using that practice, they don't have to tear up the walls. And as Joe and Bill were pointing out, sometimes when you tear into a wall, you find things you didn't expect or want to find. So it avoids doing that. And you go from there into the apartment. And in many cases, the problem is solved just by powering one of the appliances, like offloading the electric range then provides enough with a little load management sometimes, but it applies enough power to avoid the upgrade to the panel box itself. And in extreme conditions, we can replace the whole power requirements for the apartment by a combination of direct DC powering and inversion in the apartment. What I mean by direct DC powering is, as many folks might know, appliances are using direct current inside. When you have like a modern heat pump or a refrigerator or an induction cooktop, they convert AC to DC as it comes through the sheet metal in the appliance. And then inside the appliance, it's operating on DC power. So some manufacturers have built DC compatible appliances on the heat pump side and the induction side. So we don't have to invert. We don't have to put inverters in that location. And so after that, it's pretty fast and low disruption level for getting from that basement transmitter location to the appliances upstairs.
Yeah. So how long, using traditional methods, right? You're going in there, you're tearing out the panel, putting a new one in, maybe moving it around, tearing out the walls, distributing the MC cable. And so they're in there for days. They have to move the people out. How long's give us an idea of how long it takes to distribute the work that has to be done inside an apartment when you're basically distributing, 16 gauge wire, through, cove molding.
When the system is set up, like if you take the example of the cooking appliance, before it's installed, it has the connections for digital electricity. And so it's about 3 to 5 hours in the apartment. And that includes things using surface mounting techniques, what folk quote wire mold raceway on the surface of the walls and stuff like that. So it's pretty quick in the apartment. And I think we're looking at, including, the process of getting in and getting out and all the little details, we're looking at a 3 to 4 week project.
Inside the apartment? How long you have to stay in an individual apartment? In the building.
Yeah.
But one of the keys about using this is that we're in the apartment, a few hours, and the tenant doesn't have to leave, right? And so you don't need to set up temporary housing for these people, move them in and out. It's someone comes, the contractor comes in the middle of the day, pulls that cable, and they're out 3 hours later.
Yeah, that's right. Yeah. You do everything else first, right? You install the stuff in the basement. You're not disrupting anybody when you're doing that work. And then in the hallways, it's a little more disruptive, but you're still not kicking people out of their own apartments. And so, you get everything done, installed in the hallways and coiled before you even go into the apartments. That's one crew. And then when you start going in the apartments, you take that coil and you make the final run in the apartment and try to get out of there between 3 and 5 hours.
Mm-hmm.
Yeah, I mean, realistically, it's not much different than if you were having somebody come in and put in your internet router, if you're going to have them put the cables in nicely, right?
Yeah, that's a good example. It's a similar IT-like practice.
Yeah, it's exactly the
that's
same
where it can
scope
be
of
a
work.
schedule. Yeah, it can be a scheduled process where you're seeing, say other, but like your satellite or Ethernet. But yeah, you see this used quite a bit in Europe. I mean, they deal with these older buildings, right? They have buildings a lot older than 100 years old there. So it's, we're seeing those practices there that have been done for years start to migrate themselves here.
Mm-hmm.
Yeah, I think Joe and Bill would agree that when you're in those buildings, if you are tearing into anything, that's where the scary stuff happens. Because as soon as you try to tear into walls or like expand risers, or there's stuff in there that you might not have wanted to find.
Yeah, you're potentially opening up a whole can of worms,
Yeah.
With this, you're drilling probably one small hole from the corridor into the apartment. And if you really need to, depending upon if there's lead-based paint, you can get drills that have HEPA vacuums as part of it. But if I'm starting to chase channels out of walls and everything else, I could potentially be setting myself up for having to be in abatement zone.
Yeah.
Yeah, that's a good point.
Well, and it's just that is lead paint. There's just, like you said, it's just we can start going down the list of the things that have been banned that could be in those buildings.
Yeah. Yeah, these guys were worried about us. They didn't even want to put screws in the wall. When we were talking about putting molding, they're like, okay, but we had to work on ways so they didn't actually have to put a screw into the ceiling because, the whole building's hot.
Mm-hmm.
Yeah.
Some things
Go
are
outside, try to dig up outside. Is how many graveyards you found in New Orleans or Boston or whatever.
Yeah.
People didn't mark graves back 100 or so years ago. So, I've actually had some other companies that are well known in the EV market. They've dealt with that right now, digging up stuff out. Ooh, okay.
Oh,
and that totally stops the project for years.
A dead body. Yeah.
Yeah, it's just finding a graveyard. I mean, you'll be surprised at how many family grave sites, that are there still in the city that used to be part of the country, and that's just it happens all the time.
All right, so I'm going to sum it up. And so in terms of like the scope of work, we're basically installing, you go into basement, you have a building that has, using traditional methods, they would need a service upgrade and build new panels and a new electrical risers. But what we're saying is there's this alternative world where you use digital electricity and you're basically installing something that looks like server racks, 42U racks in the basement, that you connect that to your service, that transforms the service energy or electricity into this thing we call fault managed power, digital electricity, that now you can distribute using 16 gauge wire, through the same like raceways that you'd use for communication wire, like as if you were installing in like internet access points. Get into the apartment, you're using cold molding, quick connects to power this receiver that converts the power back to the form of energy that the stove or the heat pump uses. You're in and out of the apartment in 3 hours. And on top of that, by connecting everything, with digital electricity, you've networked all the appliances. Like anything that's powered by digital electricity is now networked by digital electricity. So you can use these sophisticated load management strategies to make sure that the total demand for the building at any point in time doesn't exceed the current service rating. And so no phone call to Con Ed. Did I miss anything?
I mean, that sounds pretty complete. The thing that really makes it click for me is that load management aspect, right? Because when when this first came on and started to investigate it, it's like, well, watts are watts, right? If the stove needs a certain amount of watts to heat stuff up, they're coming from somewhere. Whatever voltage it's at, my amps are going to correspond accordingly. So where is the gain? And really it becomes being able to do that load management, load sharing, and managing those devices is where you can keep that capacity down.
Yeah, this is this weird empirical thing we would try to figure out. It's like people, the service actually coming to the building there's often plenty of it to power everything. It's how you do the load calculation and the other limitations, just the feeder, the rating of the feeders. So if you can manage, you actually have a significant amount of energy that you can, if you budget it correctly, you can upgrade these even these 40 amp apartments. You can fully electrify them. That's what I find amazing.
Yeah, James, I think you're going to see more of that in this industry. I mean, we talk about our infrastructure and our grid. There's other demands besides just what you're talking about here. Is EV, all these other renewable, all the stuff that we're seeing out there is our infrastructure sometimes just can't get there. So, we always think when we design stuff, the 100%, all the time, it's designed that way that it's going to use that 200 amp or 100 amp service, but they're not, right? They're not using all that power one time. And so now with this new, like Joe says, it's load management. That's the new key, is that using the energy that we do have efficiently. And I think you're going to see more of that. And this digital power is a part of that transition into that type of a world.
Yeah.
Is, really managing and knowing what we're using. And you're seeing more from in all these industries, smart breakers, where now they're looking at the power usage as what they're actually using on a circuit. Can we download, or can we turn it off? Can we do those things? So I think we're just getting smarter. We're going from the hammer to the more refined thing. It's always bigger hammer works. Well, the bigger hammer doesn't work in this way. Let's get more practical with this.
Yeah, we're more constrained. It's like it takes.
We are.
18 months to get switch gear.
Well, there's a lot of industry factors like that. It's a lot of people love to get EV, but they're waiting 9 months for a transformer.
Yeah.
I've actually seen some chargers out there on a generator or a battery or a solar system because it can't get utility power yet. So, it is a give and take, but you're going to see things transition. And I think this is just part of that, but it's just grasping, and the education is a huge part of this, grasping the concept.
Yeah. Yeah. There's people listening to this right now. There's an electrician or listening to this podcast right now. And there's a question they want to ask. Is there's something they see or they're suspicious of that doesn't work with digital electricity. So Bill, Joe, if you guys could do me a favor and just throw out some hard questions. Put yourself in that person's shoes right now and try to imagine what question that these more skeptical people have right now about digital electricity.
Joe, you want to go first?
Yeah, sure. Just a couple out there, right? Like one, and we broached on this before, is the building authority okay with me doing this? Right? Am I going to get into inspection hassles down the road? Two, does this actually work? Does it make sense? Where has it been used before? What kind of examples? Because I don't want to be the guinea pig and do all this and be on a hook for a system that has issues, right? And so what case studies are there out there? Another one that kind of pops up, and Steve brought up on the licensing requirements, is who installs it, right? Because it is kind of this weird game. You can install it like it's low voltage, but it's not low voltage, and a lot of jurisdictions kind of have a line at 50 volts for being an electrician versus a low voltage contractor.
Okay, that's a great. So, Steve, we had 3 questions. He had, what's the inspector going to say when they see this? Who installs it? And where has it been installed? Are they going to be a guinea pig if they use this? And who installs it?
Yeah, right now there's,
We crossed 1,000 large buildings for the installation base for digital electricity a little while back. So it's installed in the majority of NFL stadiums in America, a good chunk of the major airports, some big hotels and smart building applications. There's some kind of cool case studies on that. And our latest market, also indoor farming, right?
Yeah,
Vertical
greenhouses. Yep.
and this is one of our latest markets, is what we call electrification, where we're going sort of deeper into it. Before, we were powering things like, like lighting and controls and small appliances and things like that. And with the new FMP standard, what we call our Generation 3 products, now we're at the point where we can power really big things like induction ranges. So I would say that we often educate and look at our customer base and how our customers have traditionally been folks that are very, very dependent on reliable power. We started in telecom, where the customers are the major phone carriers, and moved into buildings, and those buildings have been operating like hotels have been operating for years and years now on digital electricity very well. So I think we cover that, a lot of that with education. The code, again, I think it was a really good point that folks, they're not always up to date on the latest things coming out in code. So that's a sort of a joint effort with manufacturers and industry organizations, and also the safety organizations for education. And there's been a lot of good cooperation there. Yeah, I've always found out that inspectors are, if you don't blindside them, if you kind of give them a little advance notice, hey, there's something going on here that's a little different. Why don't we do a little education on it, rather than just cornering an inspector, in 15 minutes and trying to get a check on a box. It works a lot better.
Yeah, and everything's listed, right? You can look at the nameplate of our products and they're listed.
Yeah, that's the beginning of it, to make sure that everything is listed equipment, right, to be put in buildings. But it's, digital electricity, like we used to, we heard the Martian shit comment.
Yeah.
It's not, not intuitive. It's very different.
Well, here's some things I think, my question was habit, how you overcoming that habit. But, a lot of people, when we introduce basket tray or welded wire tray into, if it's so good, why isn't everybody using it? To Steve, so, how would you answer that question? Is that this is so good, why isn't everybody using this? Why isn't it a widespread use thing now?
Nice question, Bill. We get that one a lot too. Go ahead, Steve.
We do get that a lot. And I think it's a big world out there in electrical infrastructure. Sometimes I say this in talks, is that if you look out on the street right now, it looks pretty much the same now as it did 100 years ago. Like it's not an industry that changes very fast. And so I think the reason why it's not out there everywhere is because just everywhere is a really big place in electrical infrastructure. As I mentioned, we're in like 1,000 buildings, and that's just still a drop in the bucket. People haven't, there are a lot of people run into that haven't heard about it before. So I think that's a big part of it, is just moving a way of doing things. AC distribution has been around from the beginning. And, changing the way folks do things. Like, it's a lot easier to just stamp a print from a previous building than it is to look at a new way to do it. And it's often brought in by the owners, like the owners who are the ones who in the end benefit for improved infrastructure. It's not really the folks that are putting it in, because they're actually, it's less risky for the folks if they just do it the same way they did it last time. So it's sort of a combined effort of being pulled through by the folks that are the ones that really benefit from the change, and educating.
Well, that's where I saw a lot of that that's why I said the word habit first. They're very comfortable with what they've done before, and they know how to do it because they've done it before, and they know how to bid it. That you introduce something new, they don't know how to even bid that kind of work because it's something they've never done before. One thing that I can tell you that went back to, and I think it's education. If, we refer back to the cable trays, I never did have a engineer who really did a building with cable trays as a structure, to carry the electrical cable. And I kept digging in as at their education level at college, they never had a use case where they had to calculate tray versus conduit. That's why they all use conduit. The base of their education at university, electrical, when they're getting their electrical engineering degree, was calculate everything using conduit. And so, even back to this, they're calculating all their loads based on AC power, what's used today. So even at the engineering level, it's something new. Is that how do you calculate this stuff? So it's back to the basic education and habits. Is how do we break those and get this out there?
Steve,
you're a drop in the bucket.
Steve, you have to set up some endowments. That's what I'm hearing.
I'm sure you'd be first in line, brother.
Yeah. All right, lightning round. This just came to me. So we have we're starting a podcast. I love podcasts, and there's always intro music. So, and we're targeting engineers and people like you. So, Bill, what type of music should we use for intro music?
Oh, I'm sorry.
Oh, Saved by the Bell. Hey, Joe.
Bill went ahead and phoned a friend.
Sorry, phone a friend. It's Back to the Future, and I don't know. Future so bright you got to wear shades, kind of thing. Maybe.
My God.
Sorry about
I think
that.
something that pops to the top of my head, just because
Back
it's
to the
more
Future?
recent, is Thunder by Imagine Dragons.
Thunder.
Yeah,
That's my son. One of my son's favorite songs. Steve.
You guys know what a theremin is?
No idea.
No.
It's like an instrument that has two long wires sticking up vertically. You put your hands next to it. It goes.
Oh yeah.
That's the beginning of Star Trek.
Yeah.
Yeah.
All right. Okay. Well. Okay. The right answer is electro swing. Okay. We're gonna.
Okay.
All right. No idea. We're gonna. Steve's a CEO, so sounds like we're gonna have antenna music or whatever he's talking about.
Antenna music. That's
Antenna
what we
music.
do
Yeah.
Star Trek too.
Yeah. All right. Well, we'll leave it there. Thanks so much, Southwire. We're so honored to be able to do something with you guys on this. You guys have such a great reputation in the market. So thanks again. And that's the end of our first podcast. And thanks for helping us set it up.
Thanks for having us.
Thank you.
See you guys.
See ya.